Physics is one of the most enjoyable subjects. It's also one of the most concept-based subjects. What this means is that if you understand it well, then you can score a lot of marks without having to put too much time into the subject. Be clear on the basic concepts and you'll be able to solve almost all the questions. What are some of the tips and tricks that can help you do well in physics? Make short notes of each chapter. Write down the major relevant formulae in those chapters and some characteristic questions of all the different types. Make sure that questions which are related to certain concepts are noted down. You'll often encounter these questions while solving and you'll have difficulty in them, or they'll be taught to you by your instructor. If you keep these short notes in a book, it will make very easy revision later on. Also, your physical intuition and interpretation of all the questions should be good. Remember, these are not theoretical questions. Physics is intimately related with everything we see around us in life. Try and apply them to real life. Understand how the problems that are being asked to you are actually relevant and related to real life. Oftentimes, a good intuition of what is physically possible will help you in solving the sums correctly as well. For instance, in mechanics, when you solve a free body system and realize whether a block is going up or down, you can imagine that same system physically. If it's clear to you that that block should be falling and you are getting an upward direction velocity, you know you've made some mistake. So physical intuition is something that helps a lot in physics. A lot of the questions are not at all numerical and can be directly solved by good conceptual thinking. A lot of the questions are explicitly designed to test concepts. You will never be able to predict all the questions that come in JEE Physics. Be clear about the basic concepts and where all your conservation laws, etc. apply, and apply them to whatever situation is given. Don't be fazed if you encounter something that you haven't seen before. There are certain areas of physics, for instance thermodynamics and modern physics, where a lot of different formulae are applicable. Make sure that you know them well. Also in these places, a lot of theory is present which can directly be asked in the forms of assertion reasons and so on. If you know them, you'll be able to solve the question, otherwise you'd be stuck. So make sure that you're completely clear about all the different theories that come in thermodynamics and modern physics, that you haven't missed out a relatively small chapter like say based on Stephen's law. For the other major aspects, the simple concepts should be clear. Mechanics, electrodynamics, wave optics, etc. can all be done with just basic understanding of a few laws. With relation to the board exams, a major part of your physics syllabus is covered with the JEE and at a much higher level. So when you're studying for the board exams, you can literally go through the book realizing that you already know everything that has been taught. Only a few separate subjects may be present in your boards. For instance, some extensions of modern physics and semiconductors. These chapters are also somewhat relevant to AIEEE. Let's solve this problem as given in the diagram. We have a disk of mass m. It is attached to a spring. The spring constant is given as k. The disk is attached at its center. The spring's other end is attached to a fixed wall. When the spring is at its natural length, the disk is given a sharp initial velocity v0. Consider the moment of the inertia of the disk is given as I0 and the disk is rolling purely. Write the equation of motion of the center of the disk. It's important here to note that the disk is rolling purely. That is, the velocity of the point of contact and the velocity of the ground are the same. Essentially 0. There are two ways to do this particular sum. One, of course, is the force method, which we already know. However, over here, to calculate the frictional force, we would have to put into account additional equations. There is an alternate method that we can use, which is somewhat not intuitive. It may seem strange that we use the energy method over here, given that friction is a force that is acting. However, note, the disk is rolling purely. That is, the point of contact's velocity is 0. So friction is doing no work, since the point at which friction acts is not being displaced. Therefore, going by the energy method is easier over here. The total energy at any time t is equal to the energy in the spring, that is half kx square, x being the distance from the mean position, plus the kinetic energy of the disk, that is half mv square, plus the rotational energy of the disk, that is half I0 omega square. Omega here being v by r again by the condition of pure rolling. Since this total energy remains constant, its derivative with respect to time, dE by dt, will be 0. That gives us kx into dx by dt, that is kxv, plus mv into dv by dt, into 2 into half is mva, plus half I naught into 2v by r into d of v by r by dt is again I naught by r square into va. Rearranging and cancelling common factors, we have minus kx is equal to n plus I naught by r square into a. Therefore, the equation of dynamics is the acceleration a is equal to k into x into minus k divided by m plus I naught by r square. This is the equation for SHM, since a is equal to minus constant times x. We have two particles A and B. They are moving along perpendicular directions. The initial velocities of the particles are v1 and v2 respectively, and their initial coordinates are x1 and x2. Find their minimum separation and the time at which these two particles come closest to each other. There are two approaches that we can use to solve this particular question. One is a physics-based approach in terms of relative velocity. The other is a mathematics-based approach in terms of calculus. Considering the first approach, relative velocity. Sit in the frame of one of the objects, in this case v1. In that frame, the velocity of v2 will appear as the relative velocity of v2 with respect to v1. This might be at some particular angle theta. Consider the starting positions x1 and x2 and plot the trajectory of particle v2 with respect to the first particle. Find the minimum distance that is present of that trajectory from the initial position. That would be